Okay, I'm going to do rational functions. I hope that your Algebra 2 teacher covered a lot of this with you. A rational function means that I have something like this. We already know what the restriction here is, but we have a lot of different things that we're going to find on here. So we're going to find the zeros. We're going to find the y-intercept. The zeros are the x-intercepts, so I'm not sure if I call them zeros or x-intercepts. We're going to find the y-intercepts. We're going to find the horizontal asymptotes. We're going to find the vertical asymptotes. Horizontal asymptotes are what x cannot equal, which we should know that right away. Vertical asymptotes are, horizontal asymptotes are what y cannot equal. Vertical asymptotes are what x cannot equal. We're going to find the holes, and we're going to find slant asymptotes if we have to. So let's go through this. Zeros make the numerator equal to 0. So top equals 0. Y-intercept is when x equals 0. We just plug it in and find it. Horizontal asymptotes, they're kind of tricky. So I'm going to say that it's top and bottom, or numerator and denominator, but I'm just going to call it top and bottom, okay? If the degree on top, this has a degree of 1. If the degree on top is larger than the degree on bottom, and I'm talking about degrees here. If the degree on top is larger than the degree on bottom, there is no horizontal asymptote. And the reason that there's not one is because there's a slant asymptote that I need to find using either synthetic division or long division. And I'll show you some examples of that. If the degree on top is equal to the degree of on the bottom, I just divide the leading coefficients. So I'm going to put, if the degree on top is less than the degree on bottom, it's always at y equals 0. So that's what we're going to do. Now, if I have this, this should be y equals. If I have this, then there's no slant asymptote. If I have this, then there's no slant asymptote. So every rational function has either a slant or horizontal. Vertical asymptotes make the bottom equal to 0. Holes make the top and bottom equal to 0. Not plus and. So let's do this example right here. So what makes the top equal to 0? X equals -1. That's my 0. Zeros we put in roster notation because they're actually roots. Y-intercept. The y-intercept is what when x equals 0. So if I plug in a 0 here, I get 1, -2, 1 over -2 is -1/2. And I'm going to put that as a point. Horizontal asymptote, I'm going to look at the degrees. Degrees are the same. So I'm going to divide leading coefficient, which is 1, by leading coefficient, which is 1. So this is going to be at y equals 1. Asymptotes are the equation of a line, so they always need to be an equation, which has an equal sign. Since I have a horizontal asymptote, I don't have a slant asymptote. So empty set. Holes are only if there's something that makes the top and the bottom equal to 0, which there's not. So empty set there as well. I'm going to have to graph them out. So I'm going to make my asymptotes first. Oh, I didn't do a vertical asymptote. Whoops. I have a vertical asymptote at x equals 2. Vertical asymptote at x equals 2. Asymptotes, I make dashed lines. Horizontal asymptote at y equals 1. So it goes like this. I have an x-intercept at -1. I have a y-intercept at -1/2. So I know it's going to get infinitely close to my asymptotes. I know it's going to hit here and here, which tells me it's going like this. And then it has to go like this. It's not going to cross here, so it has to be above the line. Hopefully, again, your Algebra 2 teacher kind of covered this a lot. Let's do one that's a little bit tougher. Okay, so, no, I don't like that. Yeah, I do like that. Okay, so, zeros. What makes my top equal to 0? Well, if I factor it out, I'm going to have 2 and 7. Y-intercept. If I put a 0 in, I get 14 over negative 7, which is negative 2. Horizontal asymptote. I have a larger degree on top than on bottom, which means that there is not a horizontal asymptote, which means there is a slant asymptote. Since this has a degree of 1, I can actually use synthetic division. So I'm going to use synthetic division. So it's y equals x minus 2. If you get a remainder, you just leave it off. The remainder doesn't matter on the slant asymptote. Holes make the top and the bottom equal to 0. I noticed that this is going to make this 7. So that's not going to be a 0. It's actually going to be a hole. Vertical asymptote makes the bottom equal to 0. But because that's a hole, it's going to cancel. So if you have something that's a 0 and a vertical asymptote, it cancels, becomes a hole. So I don't have any vertical asymptotes, so empty set. So graphing it, 0 is at 2, y-intercept at negative 2. No slant asymptote at y equals x minus 2. So I'm going to have slant asymptote like this. It has to get infinitely close to these and touch these 2 points. So what does that mean? What that means is my line is going to be right along the asymptote the whole entire way. But I have a hole at 7. So I go to x equals 7. I see where the y is, which is right here. And I put a hole there, which is just an open circle. Means it jumps over that spot and keeps on going. I will figure out some of these problems that I give you as an assignment and leave the steps to finding everything so that it makes a little bit more sense.